Alright, guys. Okay, first of all, yeah.
This project is a little weird. It's kind of distracting. Yeah, it's like you could like fix it, but it's sort of like fuzzy.
Okay. Wrong one. I know. I'm going back. Oh, it's president. Let's do maybe dot cam. Will it still do it? Did that help out a little bit? Is it still bothersome? I can't seem to do anything about it. I don't know. Do you want me to just turn it off? Is it that? It's that bothersome? Okay. All right, guys. Hold on. Blank image. All right. Is that better?
Yes.
Okay. All right. Sorry, guys. Let's make sure we're still hanging out and everything. Okay. Just sure. All right. So I know it's assignment 5. I'm under assignment 6, but I'm working on it. But just to give you a heads up on what's going to go on with it, I'm going to give you a .h, and I've got one more thing to put in here, one more function prototype, and then I'm going to give you this .c, and your job is to make the .c for this, okay? Which will help you out a lot, and it'll help my grading out a lot, because then since you're not demoing, I don't have to argue. It has to work or not work for this test driver, okay? And then, so with that said, so I'll write on here, so assignment 5, I will have uploaded today. All right? So you have all of that this weekend to work on. Lab number 9 is on developing some of these. Some of linked list functions. Whoa. List functions. And it's to help you with assignment number 5. I can go ahead and release that early if you want me to release that early, so you can work on that too and maybe have a heads up. So I'll release early. Okay? Maybe even today, because I pretty much have it done. It's just part of what you're going to be doing for assignment 5. Lab number 10, and that we're going to be dealing with complexity, big O. And we're going to be dealing with sorting. Okay? Once again, another something to help you get to your assignment 5. Okay? So these should be good labs because they're not having you do something that's different than what you're going to be doing for your assignment.
What are we going to do for our final project?
I don't know. You know, your final project's one of those things where usually instead of you writing code, because I don't have office hours in the final week, and so what I typically do is have you like review code or review a certain research area or something like that and write a paper, okay? But it's not an actual writing lots of code, a big project to write code, because that would be awful to do to you during that 1 week where you have your other finals. What? Yeah, no, I'm not. Yeah, no, because then you're going to need help, and there's not going to be study sessions, there's not going to be TA office hours, there's not going to be me office hours unless you request to see me, things like that. And most of the time, you know, you don't like go to have your teacher help you study for your exam. You kind of do that on your own. You know what I mean? So it's not something that is a programming thing to where it would be hard or cover new material or anything like that. Now, me giving you something in review and tell me what could you change or what might you better about this or what does it do, that would be fair. Okay? And with that said, I will release that project in dead week. Yeah, not next week, but the week after. Next week we need to be consumed with our test. Okay? This weekend I want you to kind of be consumed with assignment 5 and trying the best you can with the material I've given you today. Test is not cumulative, second half of the class. But pretty much cumulative because all of that prior stuff goes into knowing about polymorphism and everything else. Okay? Linked list, Brandon said he did a much better job in this class. Sometimes that's how it goes. You got kinks in the first class. It's kind of nice having back-to-back classes, but you typically get a better lecture. But from Brandon even said to him, he made some mistakes in the first class, and so he felt like he did a better job with you guys. But I'm just going to at least review. I don't know that he gives you slides, and some of you are you really like slides or like things to put beside you for reference. And so that's what I'm going to do today, plus going to record this demo that will help you with your assignment on linked lists. Okay? So one thing I want to review about linked lists is when I say what are they, well, number one, they're a list. Okay? So what do all lists, whether they're linked or whether they're an array, what are all lists? What's an attribute of a list?
They're all the same type, at least.
Yeah, they have an order. They have an order, but I don't know that they really have an order. They do, but it's sequential, right? We could say it's a series. You could say it's sequential. You could say it's linear. These are all the different words I would use to describe this particular data structure, okay? So in that case, a list, whether it be an array, whether it be a linked list, it is still a linear data structure, okay? The difference is, and so with any linear data structure, what is your complexity? What is your efficiency based on in your program? Memory, but what about, so the complexity of that program, how complex that program is, depends on, and your program has this linear structure. The complexity and how complex that program is depends on what about that linear structure.
Sorted?
Well, that would, but even if it's sorted, still the principle behind that linear structure, everything is based on what about that linear structure? How many items are in that structure? That's exactly right. How many items are in that structure? So at the very minimum, with a linear data structure, you are going to have a complexity in your program of a big O of N. It's going to be as complex as how many items you have in your structure. If you have a million things in your structure, you had to go through for a million times and add things to it. You had to go through for a million times and print things, even if they are sorted. But at the very minimum, to deal with that data structure, or I should say, at minimum, maybe you just add things and that's one by one by one and you never print it out, right? Now that's constant. Okay. But you still have a loop. You still had to go for a loop and say you wanted to add another one. You want to add another one. You want to add. The complexity of that linearness is it's still in. Does that make sense to everybody? It's based on the number of items, okay, in your linear structure. Now, to print things in sorted order may depend on if they're already sorted. It may just be going through all in and printing them and ascending if that's how they are. Still worst case end, right? But if you had to sort those beforehand, now we're going to start going into this idea of what are the different algorithms in some way can make us, we still got to go through n things. They could already all be sorted. In worst case, it's n, okay, if they're already sorted. Chances are they're not already sorted. You're going to have to sort it at some point, or you're sorting as you go along. Okay, in which case you need an algorithm for that. Now, that is either going to be, do we go through for all of the items, for each of the items for each time? So now we're at n squared. That would be a very brute force sort. Do we start cutting things in half and going through half to half and all this kind of stuff? Is this an n log n? But at worst case, this linear structure is still going to be n. Some algorithms may make it better than an n squared or an n log n or whatever, but we still got an n complexity with this thing because it is linear. Is that making sense? So this is the idea in which we're going with some of this complexity stuff, okay? So you can have complexity within your data structures, but you can also have complexity within different algorithms that go through your data structures. So they're kind of together. All right. Arrays. Okay. So arrays. So these are. So it's a list. So we know that it's a list. Number one, first and foremost, the darn thing's a list. Okay. Could be a list of numbers. Could be a list of characters. Could be a list of grocery items to get at the store. Right. And they're linked. So if they're linked, second, this linked part, what does that mean? What are we talking about are linked? What is linked? What are linked together? The items, right. So linked together, list items are linked. And how are they linked? By each item what? By each item having the location of the next item. That's a pretty good definition off the top of my head. It's impressive sometimes. But it is. There's the list items, and it's dealing with the list items. They are linked by each of those items having some kind of location to the other one. So it's like if you were able to go into a grocery store, well, how nice would this be if you had linked lists for yourself in a grocery store, right? Because I'm sitting here thinking, man, I hate the grocery store. It's just time out of my day that I freaking don't like. And wait till you get to a family and you got to go up and down every single aisle. You really just hate it. I used to love grocery shopping. Now I just, maybe it's when I had a kid, it made me like it less and less. I don't know. Especially in the infant stage. Anyway, wouldn't it be nice if you went over to milk and the next thing on your item was donuts. Maybe I'm creaming milk and donuts. And so your next item is donuts on your list, and when you got to milk, it told you exactly where to go to find the donuts. How sweet would that be, right? It's just like the other day. I very rarely go to Fred Meyer. Could go straight to the stinking watermelons. Then I got so lost where the relish was. I surely would have liked to have had a linked list telling me exactly where to go to get that relish, right? Instead of asking another customer in the store because I'm lazy. Anyway, so arrays, on the other hand, so this is a list that is put together by links, okay? You could have lists like with arrays, and how was an array put together? Contiguous, yes. So basically my relish would have been right beside my watermelon. Which isn't going to be the case, right? Okay, so maybe even in that example right there, that can show you why and how in some problems it's going to lend itself to an array list versus a linked list. Okay? But they're still lists. All right, this is going to be extra credit in your assignment. It will be extra credit to have a way to push on the back and to have a tail pointer that you deal with in that linked list code. Okay, so I'm only going to require that you have a head pointer, and we're going to get there. We're going to talk about this. But if you can keep track and keep up with a tail pointer, because that's another way to have a linked list, okay? So linked lists come in all kinds of different ways, okay? The most basic linked list is just a forward linked list. One that looks like this. You have some kind of head. This thing sits, and it's a node pointer. That's its type, okay? And it sits on the stack. All right, and in the beginning it points nowhere. You have nodes that have one forward pointing next, okay? And then here's some kind of type. For ours it's an int, and then here it's a node pointer. Okay? So you have two sections to each one of these nodes. And these are all on the heap. So that's on the stack, and these are all on the heap. Okay? And then you could have several of these. Once you add this one on the heap, it points here. Then you add another one. Usually you don't add it to the back. You would add it yours. You're going to add it here. And so your head's going to have to change and everything. But you could also have a way, a linked list, where you had both a head and you had a tail. And so you kept track of both the beginning and the end of your linked list. But you're going to have to keep track of both of those pointers because it's a totally different data structure. Or not totally different, still a linked list, okay? But it helps in some situations. It makes that complexity go down in some situations, okay? You can also have a doubly linked list, okay? So in that case, you still have a head, but now you have another section on here where you can point forward or you can point backward to lists, to other nodes, okay? So you'll have two pointers in some, all right? This is your binary search trees, have nodes like this because you got two things pointing down to more stuff, okay? So every node has a value, and then it's got two pointers to go down in different directions. You can have what's called n-ary trees, where now maybe you need a dynamic array of node pointers. Some of them have 2, some of them have 3, some of them have 5. Yeah, am I blowing your mind yet? If you're ECE, okay, you need to at least be in this enough to get through your next class. If you're a CS, you better love this stuff because it's your life, okay? And so it's fun. Wait till you get to compilers. It's a lot of fun. It's really, in practicality, you use this all the time, okay? So if it makes your head go, oh my gosh, you know, this is getting crazy. It does get crazy, but it also gets really crazy fun, too, for CS people. You guys are like, I want out. It's okay. All right, so now let's go over this, okay? I tried to prepare some kind of little slide presentation to really try to get at what do I see as the differences between C and C++. Yes, okay, biggest. That was my biggest. What is the biggest thing? And that is, this is not object-oriented programming, okay? There are no objects. Okay? There are structs, but there are not objects. Okay? There are not there's not functionality in these structs. So those of you that tried to do that and want to argue that, get out of that habit. These structs have features, and features are it. Okay? Now, some of those features may be pointers, and pointers to different kinds of things that may make you think they look and appear like other things, but they only have features. Okay? Semantic-wise, all right, so this means no classes, guys. No classes, all right? Semantic-wise, the biggest difference between C and C++ is that the ampersand does not have two meanings like it does in C++. It has one meaning and one meaning only, meaning address of, okay? This means that the semantical difference between these two languages is C++, we got the ability to operate pass by value or pass by reference. You only get pass by value. Yes, even when you pass by pointer, it's still passing by value, but that passing by pointer, even though it really is value, is the closest thing you have, that's my approximation, not real good, right, to C++ by ref. Okay, but it's not. That's why I put the squiggly lines there. It's not equivalent. Pass by pointer is still a pass by value. The value you just happen to be passing is an address rather than a primitive. Okay, but it's still the semantics of C is always pass by value. Okay. Now, syntactic differences. So those are the two, these are two biggies, okay? Syntactic differences. These are the only syntax differences I can see in between the two, okay? Libraries in C use .h. The libraries didn't have a .h in C++, right? You still have input-output. You just have, you just scanf, which is your cin, and you have printf, which is your cout. You still have dynamic memory. Okay, you got to still put things on the heap no matter which language you're in. Remember, C++ just boils down to C. Behind the scenes, it gets translated into C, then translated into assembly language. So anything you can do, really you can do in C. Okay? Malloc. Malloc is like new. Okay? Free is like your delete. Structs. You have to use the keyword struct in front of the name in C. You don't in C++. File IO. You use a file pointer, not a file object, because you don't have objects. The other difference I was just thinking about as I was going through, I said structs have that, structs. Yeah, but that's in both of them, so it's not like it's not in one. It's just a convenient way so you don't have to put the struct in front of it. That's exactly what, I'm sorry. That was my thing. That was what brain farted me. Thank you. Variable. Location of variable declarations. Okay, so let's go through these, and I'm going to do an example where, I'm starting to run out of time, where I will run through all of these, okay? Bookmark this. This is that C book. Either go buy it or bookmark this second edition, okay? Pay attention to Appendix B. These are all your libraries. I put numbers here for all of these different things that I listed on that prior page, okay? Let's go through the differences. C++, C, okay? Notice, no .h here. .h here, okay? This is your library for input, output. The other one is your standard I/O library for input, output as well. No namespaces. Okay? That's not in C, so you don't have those right there. Okay. Still have a size, still have STR. Notice these are declared up top. You couldn't willy-nilly now declare this thing in there. If you wanted to in C++, you could. In C, you could not do that. Okay? At least in the C89 standard. We will come back to that. In the 99 standard, you could, but not in the 89 standard. By default, GCC gives you the 89 standard. By default, you want to remain in that standard because that is the standard most of our professors will run you in. Yes?
So all variables need to be declared at the beginning.
At the beginning of the function, before you do any other statement. Once you've done any other non-declarative statement, then you automatically can't declare anymore. So if you've noticed, that's why I do this all the time. If you've ever noticed why all my things are up at the top, it's because I'm an old C programmer. I do like the fact of carrying that int I down into the for loop, but I still carry over a lot of stuff from C. Yes, because you can't do it inside the loop because you can't willy-nilly anywhere in your program. Once you've done a statement, no declarations can be done again.
That's through the whole program?
That's through the whole program.
Okay, so the main, yes, just the third.
Yep, that's through the whole program. Well, now, in each of the functions, if you have a local variable, they can have their own local variables. All local variables must be declared up there before any other statement.
So once you run scanf,
Nope, you sure can't. There's not block scoping. That's what you guys are really asking about. There's not block scoping. So you know how you could make an int I in between curly braces, and now it's just to that block? See, that's gone in this because you can't put it somewhere later. Okay? You have to declare them before you get to the for loop. You have to have the pre-thought. If I need I's and J's and X's and Y's and blah, 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 blah. Yeah, exactly. Just an entire alphabet. Okay. So, notice also %D decimal as in base decimal, not as in has a decimal point. Okay? These go together. We need address of because we're changing the value at that location. Okay? So we're changing the contents of size. Right? So we need to pass the address of. Why don't we need to pass the address of at STR? Because an array, yes, name by itself is a pointer. I should have drilled the heck out of that to you. Notice %S is your string. It says read until we see a white space. CN was nice. Notice we didn't have to worry about any of those ampersands or any of that. That's why students like the CN over the scanf. Printf, now you know why I get frustrated with couts in this class, because you got to have all these little things and remember that, and I just want to keep going, right? You also say what you're going to print. Hey, I know I'm going to print the size. It's going to be here. It's going to be an int. Then I'm going to print str and the string, which is a %S string. And then this is your indel because we don't have indel. Okay? And in this case, you don't need address of because you're getting the contents. And the name of a variable by itself is the contents at that location. Yes?
I remember you saying
That's not the case because you don't have indel, so you have to take care of all your buffering.
what is that?
Don't worry so much right now about that, okay? But that's where scanf and printf get a little funky. Okay, here you compile with G++. With C++, you compile with GCC for C, straight C code. You can write C code in C++, and that C code would work with G++, but when you're writing C code, you need to be in GCC, okay? And then this is just to show you that those two programs are exactly equivalent and exactly, I did the same thing, okay? Structs. The nice thing about C++ structs is the ease of just saying node whatever that struct name was, we didn't have to put the struct keyword in front of it, okay, when we were declaring things of that type. Also notice that we also had C in standard lib for our null, and it did not have a .h. We have to have struct in front, unless you type def. You could type def as well, but by default, you have to have the struct in front. Okay, that is the one difference. Anytime you declare of that type, okay? So you have to say what that type is. And if you think about that, that's just to say, hey, this is a struct. Before, even structs were treated as objects, so you didn't need the struct name because node could have been a class, could have been a struct. Everything's an object, so doesn't really care. That's why I'm guessing. I have no idea why they dropped that particular feature. But in here we have .h and because of the null. Okay, but otherwise those two codes are exactly alike. Dynamic memory. So in dynamic memory, we said new node and we said delete. Okay? In ours, we would say malloc, and this just says allocate memory for this amount. And for, in our case, the size of the struct node. Okay? So how much would it allocate? Well, on our server, this is 32 bits. This is 32 bits. So this malloc is going to give you 64 bits on the heap. Okay? And then we use free, and free goes in hand with malloc. So however much you put on the heap associated with this right there will be what it deletes, okay? So if you needed an array or you needed some number of nodes, then some number of nodes, okay? And free, we do not need to put the array thing because it says just go back to malloc, whatever malloc put in head. If there was a splat head, then of course splat head would have something, so it would be what would malloc put in splat head. It always goes back to what did it put in this thing, and if it put num times however many nodes, it's going to take away num times however many nodes. All right? Now that's not to say you don't have to keep track of the order in which you allocate things, same as in C++. You need to deallocate in reverse. All the same constructs hold, okay? Remember, I mean, it's still programming, okay? We're not going to do a quiz, so don't worry. I'm going to try to let you out here in just a minute. But I do go through this, okay? So I made you a list, okay? We're not in C. And this is where I left off right here, okay? So what I want you to give me is, we're going to do two things real quick, and then you can get out of here. I want you to give me the code for how am I going to put a value in this node. How am I going to create a node and put a value in the node? So how would I ask the user for a value and put it in that node that was just created? Scan out, well, let's be lazy, okay? Say we said enter an integer, but we're not. All right, so enter an integer, user. Percent %D, we're getting a decimal. Where are we putting that into? Where are we putting it? At val. So how do I get to val, guys, from this? No, do I call it node? I call it head. Head, what'd you say? Arrow, val. Is that all I need there? Address. Yahoo. Because what am I? If I were to put this in any other integer, wouldn't I have to have an address of? Because I'm saying put something in that num. So I'm passing it the address of num so I can fill num. So this is the same way. Once we got, look at this in two steps. Look at this as head, val. That got me to the integer. Integer, now I need to pass the address of the integer to be able to fill that integer. That's why I'm doing this with you, just to make sure you have something to go on. Is that cool? Now, how would we print it? Was somebody going to ask me something? I felt like I heard somebody saying something to me. And then what do we want here? %D. Let's give it a new line. And what are we printing? Good job. Head, arrow, val. All right. That should be the code that we need in C to be able to create a node and to be able to put something in there. Okay? And this should also, you should be able to put your next to null. I'm not doing that right now. I'm just putting values in, but you should have next. Sorry. But you should be able to put your next or assign it null from this example. Okay? So let's go through. Enter a number, remember? And we got 3 back out of that node. Okay, one more thing we're going to do real quick, and then you can go enjoy your nice long weekend. What if I want to now ask the user for how many nodes to create? I want to ask the user for how many nodes to create. %D, okay, how many nodes? Where I made a num up here for this occasion. How am I going to use num? Ampersand num. Okay, so now how am I going to make that many nodes? Head.
And times 2 or times.
Okay, I always do it this way. I want to make num of these. I don't know. You can do it the other way, obviously, but. Yes, unless it's an array, because the array name by itself is always address of. Good to know, yes. All right, so now we have a number of these. How can I go in a for loop? Int I. Well, let me just go back, okay? I'm going to show you things because, of course, I like to show you many things. Num I plus. Now, what do we need to change in here, guys? I've already allocated memory. Now I'm trying to fill. How am I going to fill now? Yes, okay, so my head is now an array of I things. Do I need a dot or an arrow? Dot, good job, my Miss Heidi. I'm so proud of you over there. Because it's already dereferenced. I'm so proud of you guys. I just love you guys. Oh, I'm going to get teary-eyed. I don't like when you leave me either, especially lots of you that I've had for like a whole year. It's so fun to watch you grow as students. Okay, anyway, as Jennifer's getting teary-eyed, that's never happened before. I'm looking at the wrong screen. Okay, so now we're going to go through here, and now we're going to get this many, okay? You all said, I can't put an I in that 4, right? So let's go and give it a whirl. Yep, it says, you moron, you can't do this with, you know, the 89 standard by default. That's what it runs in. You can change that, okay? But don't do that to, you can if you know you're programming for yourself, all right? But if you have another professor, you don't know if they're going to use this option or if they're just going to run it straight with GCC, okay? So be careful, all right? So let's run it with this. Yippee-ki-yay. Now I can do that because the 99 standard started picking up on some C++ stuff, and they started kind of going, maybe we'll start doing some things, you know, and start adding some features. But pedantic mode will also put you in that 89 standard, and some people feel that if you're not doing it in pedantic mode, you're not really writing C, which is the 89 standard. Anyway, whatever you want to think
Not
about.
writing in binary either. So
We're not using punch cards anymore, are we? Okay, let's make 3 nodes. All right, so let's do 3 nodes. Remember that was enter how many nodes you want to make. We're going to make 3. Now enter the number for your first node. Let's put in 2. We'll put in 4. We'll put in 10. And looky there. All right, go enjoy yourself. You have a video of this. And let me stop this video. And hopefully that helped.